We want to determine if these various functions are even or odd, and the algebraic test to determine this is to replace every x in the original function with negative x and simplify. After you've simplified, if the equation, if it looks like the original, then your function is even. Graphically, that's symmetrical to the y-axis. And if after simplifying, it looks like -1 multiplied by the original, then the function is odd. And graphically, that means symmetrical to the origin. Okay, so let's take a look at this first one. Off to the side, I want to go ahead and take a look at what would it look like if it ended up being odd. So if I took -1 multiplied by the original function, I'd have -1 times this. Now -1 times a cube root, is just a negative off to the side. And if it was even, we would be right back to the original. So let's go ahead and perform the test, which is replacing every x with a negative x. So I'm going to turn this x right here into negative x. So making the substitution. Now let's simplify. 5 multiplied by negative x is negative 5x. And we're looking to see, does this look like -1 times the original, or does it look like the original? Okay, it's definitely not the original. And a negative, you can't factor out negatives. There's no such thing in roots. So it does not look like -1 times the original. So this particular function is neither even or odd. Okay, we're going to look at 2 more examples. Okay, so for this one here, if this function ends up being odd, then it's going to look like -1 multiplied by the original. So if I take -1 times the original function, remember algebraically, if you multiply a fraction by a negative, you have 2 choices. You could multiply the numerator by the -1 or the denominator by -1. If I decide to distribute the negative through the numerator, -1 times 1 is -1 over the denominator. If I decided to distribute the -1 through the denominator, -1 multiplied by this denominator would be -x squared minus 8. And if this ends up being an even, then we're looking for it to look exactly like the original. Okay, so let's perform the test. Replace every x with -x. So replacing that x with -x. Then let's simplify. -x multiplied by -x is x squared, and we are right back to the original. So since it looks like the original, this function is even. But if it would have looked like either one of those, it would have been odd. Okay, here's one more. Let's take a look off to the side. What would it look like if it was even? So if it ends up being even, it's going to be -1 multiplied by the original. And we have addition here, so this -1 would get distributed. So this would be -x squared absolute value of x minus 9. Okay, just distributing that through. And then here, if it was even, then it would look like the original. So let's perform the test. Replace every x in the original function with -x. So this x and this x with -x. Then let's simplify. -x times -x is x squared. Absolute value of -x is x. So it looks like the original. So this function is even. But one more time, it's kind of nice off to the side to multiply your original function by -1 and simplify. so you know what you're looking for when you simplify after replacing the x with a negative x.